All right, today we're going to get started kind of with an example of something known as hypothesis testing. So we're going to go through an example without kind of knowing what all of our formal definitions are and kind of walk through a scenario where we'd want to use hypothesis testing. So let's say that there are two graduate students, Eric and Adam, that are convinced that the Coca-Cola company is ripping them off. They firmly believe that their 20-ounce Coke bottles are often underfilled, and so with this in mind, they decide to test their theory by creating some sort of sample. Eric and Adam decide to measure 67 Coca-Cola bottles in order to determine the amount of Coke in each of them. On average, they found that the bottles had 19.67 ounces of Coke with a standard deviation of 0.45. So this 19.67 is less than this 20. So it kind of has led Eric and Adam to believe that perhaps Coca-Cola is ripping them off. Well, that wouldn't be very good. So what they are going to want to do is they're going to want to go ahead and try to figure out how likely it is that if Coca-Cola is not ripping them off, how likely is it that they're going to get the sample that they got. So if they're not ripping us off, how likely is it that we get this? So what we're going to do is we're going to start by assuming that Coca-Cola is not ripping us off. Now we want to know what is the probability of obtaining this sample. Or something more convincing. So more convincing would mean something where it was even lower of a probability. Or even lower of a number of ounces filled, rather. So let's kind of review the information we have. We know that our sample mean, X bar, is 19.67. We know that our S, our sample standard deviation, is 0.45, and our sample size is 67. Now, the thing we're assuming is that our population average is 20 ounces. So this is the assumption that we're not being ripped off. You know, it could just be that some of their bottle machines are underfilling a little bit, but maybe it's not true for all of the bottles. So we need to test this assumption. So our alternative we're going to call it a hypothesis here, is what we believe, which is that the average that they're filling up the bottles is actually less than 20. So what we are testing. So let's say we want to know how likely it is, or our probability of having our X bar equal 19.67, our S equal 0.45, and our sample size being 67, or something crazier. So remember, or more convincing rather. So remember that if we try to do the probability of a single point, since this is something that's a continuous distribution, we're going to end up getting 0 for the probability. So we want not just how likely it is to get this, but how likely is it that we got this or something even, worse for Coca-Cola than this. So since we know our sample mean and our sample standard deviation, but not our actual population standard deviation, we're going to use the t distribution here. So remember that for t, we're looking at x bar minus mu over the standard deviation from the sample divided by the square root of n. And this is roughly going to be our t-score for t sub n minus 1. So remember, the degrees of freedom for the t distribution is going to be the sample size minus 1. So let's do that. We'll take 19.67 minus 20 divided by 0.45 over the square root of 67, and we'll get roughly negative 6.00. So this will be our t sub 66. Let's kind of review what we're talking about here. We're saying that we have a t distribution, which remember is similar but not exactly the same as a normal distribution. So this is t sub 66. It has a mean of 0, and we're saying that our value here, our particular cutoff, is negative 6. And so what we want to know is how likely is it that we end up having a value of negative 6 or something more extreme than that. So this area equals this probability that we want to go ahead and find. So we need a way to find that. So in order to find this probability, I'm trying to decide which pen I want to use. We're going to find the probability that our value in a t distribution with 66 degrees of freedom is less than or equal to negative 6. So in this case, we'll use t CDF. We'll go from negative infinity, our lower bound, to negative 6, and we have 66 degrees of freedom. So remember, we have lower bound, upper bound, and degrees of freedom as our inputs for TCDF. And this gets us roughly 4.58 times 10 to the negative 8, which is pretty much 0. So what this told us is that if Coca-Cola fills to 20 ounces on average, it would be very unlikely, probability of basically 0, that we got our sample. So then what's our conclusion with all of this information? Well, what we'd like to conclude at that point, go back up here, is that Coca-Cola is likely ripping us off. Well, that's not good. So that's kind of the main process and idea that we're going to end up following along with when we're looking at some hypothesis testing. We'll start off with some sort of assumption, and we'll have some sort of thing we're trying to test, and then we'll use our information to figure out our probability that the assumption is true. And if we get something very, very small, very low probability, then it's going to lead us to believe that our assumption was wrong, and that, in this case, Coca-Cola is not filling their bottles to an average of 20 ounces. They're filling it to something lower than that. So let's compare this to something like a jury trial. So just to kind of get some more analogies for us to be thinking about as we look at kind of the nuts and bolts of hypothesis testing. So let's say we are looking at a jury trial and comparing it to hypothesis test. If we're assuming that the defendant is innocent, this is similar to saying that the null hypothesis is true. So the null hypothesis is going to be the thing we just assume baseline is true when we're trying to test. In our example on the previous page, it was the idea that Coke was not ripping us off. Then there's the claim that's being tested. So in a jury trial, if we're assuming the defendant is innocent until proven guilty, and so the claim is that the defendant is guilty. In a hypothesis test, we have a similar idea. We're going to assume that the null hypothesis is okay until it's proven otherwise. So here the claim that we're testing is that the alternative hypothesis is true. So from the previous page, this would be the claim that Coke is ripping us off. Now, typically in a jury trial, you'll then have us to actually support this claim. So you have this idea that Coke is ripping us off, or that the defendant is guilty, and in order to support it, the prosecution brings evidence. In a hypothesis test, we're going to have our sample data that we use as kind of our evidence to try to support our alternative. So once we have all this, there's a decision-making process that we have to go through. So in a jury trial, we're saying that if the defendant is innocent, how likely is it that there would be all this evidence that's implicating the defendant? In a hypothesis test, we're saying that assuming the null hypothesis is true, how likely is it, or what is the probability of getting this particular sample or something much worse? Now, let's say we've got a certain amount of proof or enough evidence to show that they are guilty beyond a reasonable doubt. So here, this would be similar to a claim about a p-value. We don't know what p-values are yet, but we can kind of come back to this later. This is saying that the p-value is less than a particular significance level. Which will denote alpha. So if we can show they are guilty beyond a reasonable doubt, we then believe that the defendant is guilty. And similarly, if we get p's that are less than some particular significance level, we'll find that our null hypothesis is not true. So in a guilty verdict, in a jury trial, we'd be convinced beyond some reasonable doubt that the defendant is guilty and the assumption of innocence is wrong. For a hypothesis test, we're saying that we reject the null hypothesis Or in other words, we've been convinced the null hypothesis is false. However, if we looked at instead a not guilty verdict, what we're saying is that there's not enough evidence to reject the assumption of evidence and the assumption of innocence and support the claim of guilt. This is not the same as saying the defendant is innocent. For a hypothesis, we're saying we are failing to reject the null. In other words, there's not enough evidence to reject the null and support the alternative. Now note that if we're talking about a jury trial, something we never say is that the defendant is guilty, or the defendant is innocent. Right? Just because we have enough evidence, or we don't have enough evidence to prove their guilt, doesn't mean that we've proved their innocence. Similarly, we're never going to say that the null is true. Right? Just because we don't have a reason to reject it doesn't necessarily mean that we're saying that it has to be true. Just this particular sample didn't happen to give us enough information.